So today we're looking at lesson 4.2, which is on adding and subtracting radicals. For the essential question, I want you to answer, how are you able to add and subtract radicals if the radicands are not the same? So for our vocabulary, our only term today is called like radicals. And like radicals are radicals with the same index and the same radicand. So for example, like radicals could be something like 5 rad 6 and -3 radical 6. So you'll see here that both of these have a radicand of 6 and both of these have an index of 2. Therefore, they are considered like radicals. Now, this is very similar to having like terms. For example, like terms could be 5x and -3x. We have the same variable to the same degree or the same power, and that makes them like radicals. Now, similar to like terms, in order for you to add or subtract them together, you have to have like radicals. And when you add them together, you simply combine the coefficients. So if we had 5 minus 3x, that would give us 2x. And similar to that, if we have 5 rad 6 minus 3 rad 6, that would give us 2 rad 6. And so just like with the like terms, when we add or subtract them, we simply combine the coefficients. The same thing is going to happen when we add and subtract radicals. So for GP number 1A, we have 3 rad 5 minus 4 rad 2 plus 5 rad 5. So the first thing we want to do is determine which of the two radicals are like radicals. So you'll see here we have square root 5, and here we have square root 5 as well. So we can combine those two radicals together. So I'm going to go ahead and I'm going to stack my radicals just like we did when we were looking at like terms. So we have 3 rad 5 and 5 rad 5, which are like radicals, minus 4 rad 2, and nothing to combine that with. So if I go through and add them together, this is going to give me 8 radical 5 minus 4 radical 2. So again, we must have like radicals in order to add or subtract them together. And when we add or subtract them together, we simply combine the coefficients, the number outside of the radical together, to give us the number of radicals of that we have. So for GP1B, you'll notice that we have 3 different radicals that do not have the same radicand. And so as is, we are unable to add or subtract them together because the radicands are different. But also notice that these radicands are larger than the ones we saw in the previous slide, which means we could probably simplify these radicals first. So the first thing that we're going to do when we don't have the same radicands is we're going to see if we can simplify them. So we're going to go ahead and we're going to cake 8. We're going to cake 45, and we're going to cake 200. So starting with 8, the smallest prime number that 8 is divisible by is 2. 2 times 4 gives us 8. The smallest prime number that 4 is divisible by is 2. That's 2 times 2, and 2 times 1. So we're looking for pairs. So 2, we have 2 2s and a leftover 2. For 45, it is not even, therefore it is not divisible by 2. 4 plus 5 is 9, so it is divisible by 3. 3 times 15. also divisible by 3, 3 times 5, and 5 times 1. We have a pair of 3s and a leftover 5. Then for 200, that would be 2 and 100, 2 and 50, 2 and 25. 25 is not divisible by 2, nor is it divisible by 3, but it is divisible by 5. And that gets us down to 1. So we have a pair of 2s, a pair of 5s, and a leftover 2. Now, when we look to put this all back together, we have a pair of 2s and a leftover 2. So that leftover goes back inside the radical, and one of the pairs goes out in front. But from the original expression up here, we have that -5 that we have to multiply to that outside number. Then for our middle one, running out of room here, so I'm going to move down here. We have 2 times, because that 2 was here to start with. We have a pair of 3s and a leftover 5. The pair goes outside, and the leftover goes inside the radical. For the last one, we have 2 pairs. We have a pair of 2s and a pair of 5s. So one of each of those is going to go outside of our radical with a leftover 2 on the inside. And again, we have that 3 that has to be multiplied out in front. So we have -5 times 2, which is going to give us -10, rad 2, plus 2 times 3, which is 6, radical 5, plus 3 times 2 is 6, times 5 gives us 30, radical 2. So you'll see once we simplify, we now have like radicals, which means that we are able to combine those together. So I'm going to take that 30 and I'm going to stack it with the -10 since they're both radical 2s. And then I can go through and combine my like radicals. So I have -10 plus 30, which is 20, radical 2, plus 6, radical 5. So when those radicans are not the same, the first thing we want to do is cake them to simplify to see if we do, in fact, have like radicals after they are simplified. For question C, same thing. We don't currently have like radicals, so we're going to go ahead and simplify the radicals that we can. Now this is 2, it's a prime number, so we're not going to be able to simplify the square root of 2 any further, but we are going to try to simplify the square root of 50 and the square root of 27. So 50 is divisible by 2, that's 2 and 25. 25 is not divisible by 2. It is not divisible by 3. It is divisible by 5. So here we have a pair of 5s, a leftover 2. So our leftover goes back inside the radical, and our pair goes out in front. And then I have to remember to put that -3 out in front and multiply that to my outside number. For the 27, it is not divisible by 2, but it is divisible by 3. 3 times 9, 3 times 3, and 3 times 1. I have a pair of 3s and a leftover 3. So that's going to be 3 rad 3. And my rad 2, once again, cannot be simplified, so it'll just remain the square root of 2. Now remember that there is an invisible 1 out in front of this rad 2. So when we go to combine it with other terms, we do have to account for the fact that there is one of these radical 2s here. So keep that in mind. So if I simplify my outside numbers here, I have -3 times 5, which is going to give me -15, radical 2. 3 rad 3 is as simple as it gets, and rad 2 as well. So for the combining of like radicals, I'm going to combine the negative 15 radical 2 with the 1 radical 2. So I'm going to go ahead and stack that. So negative 15 plus 1 is going to give us negative 14 radical 2. And 3 radical 3 can't be combined with anything, so it remains just the same, giving us a final answer of negative 14 radical 2 plus 3 radical 3. All right, last GP. We're looking at a triangle and we are asked to find the perimeter. So let's remember that in order to find the perimeter, it's going to be equal to the sum of all of the sides. So for a triangle, that means we will add all 3 sides together. If it were a square or a rectangle, we would add 4 sides together. Or whatever shape it is, you simply add all of the sides together to find the perimeter. So for this triangle here, we're going to add up the sides of 2 radical 2, the square root of 12, and the square root of 32. So we have 2 radical 2 plus the square root of 12 plus the square root of 32. Now again, none of our radicand are the same, therefore we do not currently have like radicals, so we need to go through and simplify whatever it is we can. I cannot simplify the square root of 2. I am going to try to simplify the square root of 12 and the square root of 32. So if I take 12, that gives me 2 and 6, 2 and 3, and 3 and 1. That gives me a pair of 2's and a leftover 3. Leftovers go inside the radical. 1 from the pair goes outside the radical. And just go ahead and rewrite the first one. For 32, that's 2 and 16, 2 and 8, 2 and 4, 2 and 2, and 2 and 1. We have 2 pairs of 2's and a leftover 2. Because we have 2 pairs of 2's, that means 2 2's go outside the radical and our leftover goes inside the radical. So this is going to give us 4 radical 2, which we will then combine with the rad 2 we have here. When I combine our like radicals, that's going to give us a total of 6 radical 2 plus 2 radical 3. And that is adding and subtracting radicals. Do not forget to include toolbox items for each of your guided practice problems, and also do not forget to answer the essential question as your summary at the end of your notes.